the spiral in a shell, spiraling motion in the current.
So the last thing that we did last time was regarding the Fibonacci sequence, and we called it the quant sequence, or the J sequence. Did any of you try to find patterns of it in real life?
So I was looking around a bit, and I realized how difficult it was for me for some reason, and something that I need to work on. It didn't come as natural to me because I think it's kind of been blocked in my mind. So, and then I realized it's also like I really had to be very conscious. It's not like I would be walking along and it would just appear, like the spiral shape or the numbers, that I had to consciously look for it. It wasn't innate, or maybe it is innate, but I'm not aware of it. So
no, you do have to consciously wait. You do have to consciously see it, because this is science, and although we're talking about stuff that are natural, we are trying to find patterns of the cosmos, which is so full of detail and different kind of patterns that we need to try really hard in order to see what's hiding behind it.
Okay, so then I'm not alone in that, because it wasn't easy for me, and I also thought to myself, gee, actually the last 2 weeks I wasn't exposed to a lot of nature, which was a bit sad for me to realize that. I usually get out quite a bit into nature, but the last 2 weeks I haven't as much, maybe because of the weather or whatever it is. So I was, I appreciated Jerry's little video because it made me think about, okay, even in something and that simple, it's there. It is everywhere, as you said in the last video. So it's important to train myself to be more aware.
Right. But it's not the only thing that is everywhere. There are other patterns that are everywhere, and today we will go over about what makes equivalentics different and what makes it more correct way of looking at reality. Up until this point, I gave you some tastings of what equivalentics can do, and today we're going to actually go into the principles that make it. Okay, so equivalentics is made of a few components. Principles, which are facts. We've been through over it, but we will go in details on each one so we can understand what kind of role they take in equivalentics. So principles, these are facts that are proven, and they are always correct, unlike laws in mathematics that can sometimes be correct and sometimes may not. Patterns, event series, equivals, these are event sequences, indexions, laws, these are the mathematical ratios, differentials, orders, and the natural order of things. Let's begin with principles. So principles are anchors that help us realize certain patterns, events, or arrays, and help us understand otherwise impossible to realize factors of reality. Principles are usually constructed of several components. Facts tested with Maclaurin machine, formulas and explanations, extracted patterns from existing ratios of reality, and examples of practical use of them. For example, the Serengeti principle. And Serengeti is a very well-known professor where I come from. It could have a very human sound to it, but it's not so human. So this is the example of that principle. If a group of chaotic individuals with a symbiotic attachment in an isolated system is dependent on a certain attachment, it is more likely to reach the main event as the system's entropy increases. This is like the scientific method of it, but bottom line, the more everything goes according to plan, the higher the chances of things to go wrong somehow. So if something succeeds every single time one after the other, it means that the more it succeeds, the higher the chances of it to fail in the next run. I experienced it firsthand last week on something I did.
You said it has more of a chance to fail?
Yes. The more things go according to plan, the chances of it failing are increasing.
Why?
So it is based on dependency. As long as it is working normally as just another part of your life, when you are starting to become dependent on it, you put more pressure on it, and that's how things break.
Okay, continue.
Yeah, so there is, so first it's a fact tested with Macallan machine. This is the formula of it. Now that right now it doesn't mean much to you. It's a rather complex formula, so it's okay. What?
May I ask a quick question? Hello? Sorry, can you hear me?
I can hear you.
I can hear you. Can you hear me?
Yes. So you said that the becoming dependent on it puts undue pressure. So in this case, though, let's say something is going according to plan, and is it better to, I guess, then operate independently, regardless of the pieces involved of a specific, operation? Is that the solution?
It's a scientific explanation of the importance of having Plan B.
Makes sense. Thank you.
So when you have Plan B, you are less dependent on Plan A, and then Plan A has a longer success rate. And I'm not saying a higher, just longer. And it's going to succeed a longer segment of time. It's more about how many times it actually succeeds. So usually we are giving it up to, well, it depends, but up to about 81% success rate for everything. And then it exponentially decreases based on that formula.
So that you're saying Plan A on its own has an 81% success rate without Plan B?
No, with Plan B.
Oh, with Plan B. Okay, sounds good. Thank you.
Yeah. So once you have Plan B, then the success rates of it succeeding one after the other, they decrease following that formula. And that formula is also important for us to set the currencies. Now, we use currencies as well for different reasons other than what humans use currencies for. We use it to accommodate different kinds of economies. And with, the nation I'm coming from is a nation of 7.5 billion people. it's one nation. Let's imagine something like the United States with 7.5 billion people. So obviously you would have different states with entirely different kind of economies. And so the currencies are used to accommodate different levels. And while currencies on Earth are used to increase the differences between rich and poor, we use currencies for the exact opposite. So the thing is that our currencies are not changing. They're not like Forex. Forex is changing every minute. Our currencies are staying the same for about 2 years, and their value is actually a future value based on an entire evaluation of what it should be for the next 2 years, and not based on the past. And that principle is very helpful in that. Okay, so I'm moving on. The next one we have are patterns, which are event series. The final equivalated result using all equivalation tools to analyze events. We only know one up until now, but in the next lesson we will learn the rest. Without finding the pattern, we can never find the pattern breakers. Just as we won't be able to find a man in the crowd without having a description first. So, Annika, you had a problem with finding the pattern because this is how you need to look at things. What you are usually seeing is the entire white stuff, and you have to kind of look deeply to find that pattern, that spiral.
Yes, I see what you mean.
It doesn't just pop to you. Eventually it will, the more you look for it, but it doesn't just pop out of anywhere because it's harder to see that pattern if you look at all of the white area.
Sure. And also because we've been doing it this way for so long, so a little training, it will probably come more naturally.
Yeah, eventually. And also in the United States, architecture is modern, so it is harder to find. In Europe, it will be a bit easier because you would have some buildings from the Renaissance era and from the Roman era, and they used to follow the golden ratio a lot more. The modern era is trying to tame the universe, and older eras try to follow it. And for just as an example of who is right and who is wrong, just how resilient are older buildings versus modern buildings.
Oh yeah, it's very evident in the United States, the quality of the structures, the material that's being used in comparison to abroad or outside of the US. It's pretty embarrassing, honestly, when my family comes to visit in the United States. It's very different.
Yeah, true. All right, so move on. Next one, equivals, event sequences. Equivals are breaks in the pattern, the entire array of patterns and its inevitable breaking points, which are what we refer to as an event. Fragmented events, divided into strings of numbers following a certain mathematical law, are the connection of equivalentics to the physical and mathematical world, and eventually to our everyday lives. Equivals are the finite representation of otherwise naturally infinite or varied concepts. For example, that, which we found it in the last lesson when we tried to follow a certain tool of equivalation to find how the Fibonacci sequences are used other than what we're seeing in front of us. So we used a tool from Equivalentics to find that pattern of 011, 011. Indexions. These are entropy arrays. These are series of main events following a certain pattern across multiple dimensions. The natural index tetragon is made of 9 squares of indexes with 9 nexuses each. These are 9 squares, and each of these small blocks are nexuses, creating a 2D array of an otherwise 4D structure. This is just one example of a tool that helps us understand and calculate true manifestation of higher dimensional shapes from a lower point of view. The indexion is made from coordinates matching some of these nexuses, creating a pattern we can follow and comprehend, but more importantly, use. So I'll give you a small example. Let's say we take that series of events and we're trying to create some kind of representation of it. What do you think it would look like?
Would that be a pyramid?
It would be, yeah, something like that, maybe something like a bell diagram. We're seeing ascending order and then a descending order. But this is what we're seeing in 2 dimensions. We don't know if this could be representing something more. So then we can start using an indexion following a certain pattern to see if maybe it can represent something else. And this is how we use the indexions themselves, and we can see that there is a different shape forming here, something like that. That you can see that it could be like a spiral,
Guys, are
but
you still
in
here?
3D. We're seeing that it's something that can become like a bell diagram, but we're not sure that we're looking at a 2-dimensional shape. So we can use the indexions, which is taking into account multiple dimensions, and maybe we can find a different corresponding shape to find 3D shapes, because this is looking like a spiral coming in from perspective, from a 3D perspective. This is not the only indexion, it's just the most common one. There are indexions made from prime numbers, from the J sequence. There are indexions created from magic numbers. What we're trying to do is usually we would create it in 2D, but we will also try to find it in 3D to see all the potential that maybe we're missing when we're looking at things just from one perspective. This is what mathematics is usually missing, because it's trying to look at things only from the smallest possible dimension. Laws, mathematical ratios. We learned in this volume about the golden ratio, which is also called the 5th law. There are 9 more laws used in equivalentics, and just to comprehend the size of equivalentics, 40% of all mathematics reside in the 8th law, and 20% of human mathematics is proven wrong by the 10th law. These were the laws. I explained to them briefly. Explained about them briefly in the last lesson. If anyone wants me to go over again what each of them are doing, I can go it, but we will cover most of them during the entire class. Not today, of course.
As you wish. You want to go over again? So be it.
I can go over again the last slide that I showed you what each of them actually means. But they won't say much to you right now because we are only starting to understand all of it. Okay, anyway, I'm moving on. Differentials. These are pattern fragments. The decimal ratio between two event sequences that are present on a certain string of natural patterns of laws without using an actual event and instead using variables. Differentials are used to determine and filter relevancy of an equivalent to the main event. Differentials are similar to equations and formulas we use in mathematics, only the answer is usually made of variables and often is more complex than its manifestation in reality. We are using them to determine a pattern that we can follow and find the next set of events or equivals from a string that we're currently seeing. So, for example, as a string, we can take 2, 5, 8, 11, 14. What is the difference between each of these pattern fragments?
3.
Right, it's 3. Now, the way that we would write it as a differential would be like that. I know it's a bit more complicated, but it eventually becomes your best friend. With that, we can figure that that the next number after 14 would be 17. The next number after that would be 20, and then 23. And of course, we can do it with just calling it 3. But what happens if you have an increase? So let's say 2, 6, 12, 14, 21 becomes a bit more tricky because then the difference between them is no longer stable. It's a bit more three-dimensional. Orders. 3D holistical index arrays. These are divided into 10 arrays that are also called orders and written as follows. Third index, order of the thirds. First index, order of the firsts. Fifth index, golden order. These orders are pre-calculated event sequences with every possible scenario to an event realization. So we usually try to match an event to one of the arrays before trying to calculate a new one, as they are proven to be more perfect. This is for example. So how do we actually use them? So let's say we are trying to determine the soul profile of someone. We are taking the frequency of someone's aura and comparing it to the aura of quartz, which is the white order, something else. And by seeing the difference between those, we can find the origin of the soul, how the soul is made. Quartz is going to be the same no matter where you put it, even in outer space. The soul is going to be different, and those differences is what we use in order to find the origin of the souls. And the last one is natural order of things, stacks. Natural order of things, it's not logical. Sutrino Tao checked. Stacks is not the logical order of things, but a summary of reality. Since reality is everything we can understand and everything we cannot, the best way to explain reality is through infinite concepts. But our logic is limited to finite concepts. So in order to accept reality for what it is, we must accept the fact we will never have all the answers. Stacks following is trying to calculate reality without fully understanding the result or the way that we got to them. So for example, an absolute ratio this is what we're usually using in equivalation, is a reality breaker, because we're using something that doesn't make sense logically in order to find something that may not have a logical answer. Or, for example, the fact that we're using 0 in the beginning of every equivalation of the Fibonacci sequence numbers. And 0 is an illogical ratio, because no matter how far you go down from 1 in the Fibonacci sequence, you can never reach 0. 0 is its infinite ratio. So I'm going back to just reminding on how we calculate the J sequence. And I'm just reminding you that it's not always about finding a spiral necessarily. It is about making sure that we're seeing a ratio that follows the same pattern of Jn minus 1 and Jn minus 2. So 2 plus 1 plus 1, sorry, 1 plus 1 is equal 2, 2 plus 1 is equal 3, 3 plus 2 equals 5, 5 plus 3 equals 8, and so on, so forth. So it's not always about finding that specific spiral, and it's sometimes about finding that ratio of the one number before what we're trying to find and one number before that.
So, for example, I think one of the easiest ways to make that concrete in our minds is like a tree, and how it starts with the trunk of one, and then it usually has two large, branches, and then from those branches, it three, and then it grows in number. The higher it gets, the more little branches there are.
Yeah, sure, we can definitely look at it that way.
Yeah, that was something I was looking at. What other ways can we look at it?
Well, I'll return to something that I showed you in the past. So, like I said, you can see it in wind patterns, hurricane, weather patterns, that you can see inside a sunflower. The golden ratio, you can also see it in the way that the human body is built. Galaxies, plants, the spiral would be more visible in 3D formations because it is a three-dimensional pattern. So I would just recommend that you try to find it in those, or even wave patterns.
Sure. Yeah, that's what I was doing as far as looking for that shape. But if we were to look at it through numbers, like you were saying, that it's not just looking at it through the spiral, but also looking at it through that number pattern.
Yeah, and it will be easier today, after today, when I explain the actual ratio.
Okay, thank you.
Leo, I have a
Yeah.
So in the white sheet, we can see, the body, and it's the human body, and it has numbers on it. I want to know, are you familiar with the Rolfing method?
The what?
Rolfing,
No.
about the fascia system in the body. Are you familiar with that?
Oh, chakra system, yeah, and the meridian points.
Not the chakra, the fascia system.
No.
I see.
Fascia.
Because
I'm familiar with it.
yeah, write down Dr. Rolfing method. Basically, I don't want to make it long, but she discovered that the fascia, I don't know if she discovered that, but she spoke about that the fascia system is where the traumas are being held. And this system actually contributes to our alignment with gravity. And if you can fix it, you will make the body align with gravity, and the energy will, will move clearly throughout the body. So that will help with people getting awakened. And yeah, because of this is the picture they use, so that's why I wanted to ask.
Well, I'll have to read about it more. I don't really. I guess there is something equivalent to that in our science. It's just not something I'm familiar with because I'm not. My field of expertise isn't in biology, but I'm sure that I can ask someone about it and see what we have in comparison.
Sure. I'd like to hear the answer.
All right. So I'll just I'll close it and jump to where we are. Okay. So we talked about last time when we tried to find the equivalation result of each of the numbers, 110, 110, 110, 110, and then that QM becomes 0. And we said that that the last stable event is what we use as the event breaker, because what happens after that is an entirely new segment. And this is why 144 is something you usually see in remote viewings, because this is the last stable event of the natural segment of the fifth law. This is also called an angelic number. But I'm starting to see slowly that people are seeing 233 as well, which is good. It just means that we are starting to move to a new era. If people started seeing up until now only 144, and now they're starting to see 233 and everything that comes after that, it means we're slowly starting to move to the next segment, to the new segment after that main event. And there was a main event where people kind of saw the 144 a lot. And I'm talking about like the awakening history of the 21st century. Can you give it like a name, maybe?
COVID?
Yeah, COVID. Which means COVID, the pandemic, was actually a main event. And it was probably one of the best things that happened to humanity in the 21st century. People see it as a bad event, but this is the event of the awakening.
Yeah, that's when I came online. So sweet.
And I believe that the specific main event is coming to an end because that's when we're starting to see the 233. That's the next angelic number.
So I have a question. So you said this is in relation to 144. How did the two correlate in terms of, let's say, 2020 or 21?
So up until COVID, some remote viewers saw different numbers, and more of them started to see the number 144 as we got into the COVID era, the awakening era, which means we are we're coming very close to that point of the main event where the last segment ends and a new segment begins, that new era. Some of the, I think, numerologists or astrologists, they call it like we were in the, I don't know, Virgin era, and we are going to the Pisces. I don't really remember. I don't know human astrology that well, so maybe you can correct me on that one. Which new era started?
If one would see more, I'm sorry, go ahead. Was someone talking?
I was just saying, are you referring to the Sophia Magdalene era?
I'm not sure. This is like the lots of astrologists said that we're moving to the new era right now, like a new frequency.
So in that case, then you're saying that the 233 would be more visible as opposed to the 144 at that time?
When we actually move to the next era, yes. And the reason that we saw 144 more and more frequently is because we were coming to the end of it. And the fact that people are starting, remote viewers are starting to see 233 more, it means we're already starting that new era.
Okay, thank you.
So yeah, it has much more meaning than people usually refer to. Because 144 is not just an angelic number, it's a historical event in the grand awakening and human consciousness. And even that is following the Fibonacci sequence. So to continue further into the practical uses of equivalation and its role in reality, we must first understand the laws of event realization. So how can we use the pattern? The short answer is we can't. The reason for that is that every pattern was meant to be broken. Every theory was meant to be tested. To each trend there is an anti-trend, but we can predict that the continuous pattern will be broken, and maybe we can even predict when. The equivalation will show us what could happen before and after the pattern breaks. The first volume is called Equivalation, as this is the basic mathematical principles of event realization, but actual equivalentics will be able to show us exactly when the trend will be broken, how, and most importantly, why. But for that, we won't only have to have all the right tools, but all of the right data as well. So, for example, we know a certain event may occur in a specific array of dates, but how can we determine the exact minute and date of manifestation? To find the answer, we must take everything we learned so far, combine it, and power it by infinity, because true equivalentics cannot be understood, it must be accepted. So before we get to the philosophy, we need to cover a few more subjects first, and we're starting with pi. In short, pi, which is psi in equivalentics, is the number of times the circle's circumference is bigger than its diameter. Basically, it's a ratio. Get used to the word psi, although I know you know it in mathematics as pi, because we are going to mostly call it psi, because the use of pi in mathematics on Earth is very limited. We are going to use a more advanced concept on steroid. So I'm mostly going to use the name psi. Sorry. The definition of the word equable in GILTL is absolute ratio. So equivalentics is the science of absolute ratios, and these are an absolute ratio. Since we're dealing with patterns here, and patterns tend to be circular, we need psi to help us calculate the range of data sequences, fragments, that are relevant to our main event until we reach that one exact event that is the optimum. So psi or pi, it has a certain ratio of numbers after the decimal point which are not following any pattern, and they are going to continue for infinity. But a computer can calculate all of them. So what do we call predictable infinity?
Wouldn't it just be infinity?
Yeah, but it's infinity that you can actually predict. And it doesn't follow any pattern. So predictable infinity is a paradox, and paradoxes are a key component of reality. Usually when we stumble across a paradox, we know we are reaching the point where we're seeing reality in its entirety, in its full form.
This is why when we were trying to equivalate pi, it said improbable.
No,
That
it's
was
not.
something
It's
that-
not entirely the reason. It's because we just took something out of pi, but the way that we use pi is actually not close to the decimal point. It's somewhere along the way. Because we know that the universe is not perfect, and when I'm saying perfect, just like in theory, we usually will not see perfect circles like that. So even circles, we must also be able to be ready to calculate them when they are imperfect. And we have to prepare to calculate the imperfection, as this is the exact moment where our pattern breaks, which is the main event. And after all, the whole point of equivalentics is find those main events. Now, you heard me say before the word perfect in relation to geometric shapes. Perfect circle, perfect sphere, perfect cube, perfect line. What does perfect means, knowing what you know now?
That it's imperfect.
That it's theoretical, because the universe isn't perfect. So this is a theoretical ratio of a perfect circle. But this ratio is just something that we use as what we would call a constant. We would compare an imperfect real circle to a perfect circle in order to find the difference between it. Because I said that before, a circle is a shape made of an infinitesimal amount of linear segments, which means because we're dealing here with infinity and we're trying to find an actual answer, we cannot just use it as is. We must use ratios. We must use something compared to something else and find the differentials between them. This is the importance of using differentials in equivalentics, because unlike in mathematics, where usually when you try to do something that has anything to do with infinity, you would try anything in your power to just dismiss infinity. In equivalentics, we always use infinity. Infinity is like the base of everything. If it's something that is not infinite, it has nothing to do with equivalentics. So that It means that we always have to find tools to integrate infinity into our calculations, and that's why it's not going to be just equations. It's usually going to be patterns that are giving us a more expanded vision into reality. So as much as psi is an important segment on its own, it is not nearly enough, because it is a closed circle, and life is much more complex than that. Time is both circular and linear, which means it can be exponential. So what do we call an exponentially broken circle?
The spiral?
Right, a spiral. So it means we must also cover the golden ratio. In mathematics, it is called phi. So what is the golden ratio? It is a ratio where a segment is divided into two parts. One is longer than the other. To explain it better, we would use a rectangular called the golden rectangle. Now here, the bigger part, A, is divided by the smaller part, B, and it is equal to the entire segment divided by the bigger part, A. It also works in 3D. Now, this is not the case for everything in reality, but this is how we create that ratio that gives us the golden ratio, which looks like that, and we call it Quan. Now, just like with pi, we have a ratio with infinite digits after the decimal point, which also makes it a predictable infinity number, or a paradox. We call paradoxes reals.
Sorry, can you repeat that? You called it what? The paradoxes?
Reals. Real is like reality. Areal is anti-reality. Now, reals and areals are related to a whole different science that measures the coexistence of paradoxes with normal events by relating to everything that is real as unreal and the opposite. But since it's math for experts, we will slightly touch the tip of the iceberg and only take what is relevant for us as we progress along. The difference between how mathematics deals with areals and how equivalentics deals with areals is that we use areals as variables that can never find a finite answer, but they are fully integrated into equivalentics, while paradoxes in mathematics are usually just like the final result. For us, it is only the beginning. Reality is a cluster of events we have managed to perceive and everything we can ever. So another example of it on the golden ratio spiral is that the spiral can go on to infinity, but if we go further down from 1, we can still go for infinity and it will never reach 0. Now the ratio between each of those squares that we're seeing here follows that same mathematical ratio of 1.618. Now, in order to predict an unpredictable event, you need to use the infinite predictable variables together with limited predictable variables, since both are embedded in the universal mathematical Coulomb pattern. Same as we would need closed circles and exponential spirals together to match as close as possible to actual reality. So just to summarize the last chapter, pi or psi helps us determine when the event is likely to manifest or the pattern to be broken, and the golden ratio helps us realize what comes after it actually does. So I'm going to create a dictionary for everything we've learned so far. So we have the event nexuses, the N, event segments, the S, fifth law event segments is J, fourth law event segment is E, main event looks like that. Circular event segments are psi, 3.1416, and exponential event segment is Quan, 1.618. Now for the next part of it. Squared pi is going to be xi, and squared phi is xon. Now I told you before that pi by mathematics isn't used in the full way, but it is used, at least pi squared is used in mathematics. Tell me if you have seen anywhere that someone is using the golden ratio squared. Anyone that learned more than just calculus? All right.
I only went up to calculus, sorry.
Okay, doesn't matter. Now, this is not the only way that we're using it. It's not just pi squared and phi squared. We're actually using more commonly the four-dimensional perfect pi, which is pi to the power of phi, and the silver ratio, which is phi to the power of phi. I'm sure that most definitely you have never seen something like that in mathematics. All right, so now I'm going to give you a small exercise to see if you are able to find the actual use of the more advanced ratios. And this is not something I'm giving you in groups. I want you to all try and find it. So find the following event segments. Yeah, let's start with that.
So you're asking us to equivalate all the way up to J16?
No, I want you to find first what is J16, J17, J18, and J19. Because right here at the bottom, you already have J16. So you know that here it's 987. But following that formula of Jn minus 1, Jn minus 2, you need to be able to find 17, 18, and 19. No, we'll go over it in a moment. I'll just reveal the entire thing, and then we'll go over it. So the missions, okay, see, it's already here. Yeah, let's go over it. J16 is 987. J17, Annika, want to tell us what it is?
1597,
Right? And then 18?
2584,
Good. And then 19?
4181.
Perfect. So this is what we're seeing here at the bottom, I think. All right, so J16. is 987, 1597, 2584, 4181. So now for the next exercise, try to divide J17 by J16, which means 1597 over 987. Do it in a calculator.
It's the golden ratio.
Right. We're always getting to the golden ratio.
Right.
Orc 1. So now try it with J18 over J60. So 2584 over 987.
It's the squared of the golden ratio. I mean, is it the square?
Yeah. This is the exon 26179 or 26180, which is also correct. It's just because calculators are based on mathematics, which is not entirely correct. But it should be 26179, and I'm sure that, what, let me even check it. Let's see. Uh, 4181 over 1597. Yeah, it is. It's 2.6180. It should be 2.6179. But this is calculation. We're using human calculators. We can expect more.
I see.
What is wrong with our calculators? What do you mean by that?
You will see that Exxon does have a finite answer eventually. That the 2.6180 will get to a finite answer, 2.6179 will not.
So I
It
noticed
has to
that
do with the way that calculators are actually doing powers, which is wrong in its basis, but not very wrong. It's like 97% right.
But I noticed, like, even doing 18 over 16 or 19 over 17, within those, they were different. Like, if you kept going. So is that what you're referring to?
I'm hearing you very muffled. Sorry.
I was saying that basically even the 2.618033813, like if you kept going, like that is also inconsistent towards the longer sort of decimal points.
Yeah.
So that's what you're referring to as well, is what I was asking.
Yeah.
It's based on powers. Okay.
It's based on powers, and the powers aren't done very well.
And so for your civilization, you use McKellen machines to get a more accurate ratio?
Well, we use calculators that has mercury inside them. The mercury stabilizes the answer to become more infinite.
So because we're using silicon, is that why, or is it also because we're using powers, or both?
No, it's for two reasons. The mercury kind of stabilizes infinite ratios, but also because mathematics isn't built to handle infinity in its day-to-day usage. So the way humans are calibrating their calculators is based on a few principles that are theoretical but they are referring to them as facts, basically without telling the world that they are just theories. It's like trying to calibrate an entire ship's navigation system based on string theory, which is kind of stupid, but that's what we have.
I have a question on the exon. The subtle difference of 2.6179 to the calculated version of 6180. How does that manifest in terms of our reality? I mean, does it?
I'll show you right now.
Okay.
So this is the next part. So this is taking it a little bit further away from where we are today. It is the difference between JNX and JNY is going to be always the golden ratio, Quan, to the power of NY. So I'll show you how it works. JX plus N. If we're trying to find JX plus N, then in order to find it, then we're taking the X that we have and using the golden ratio to the power of the N. So what is the difference between J11 and J14? J11, J14, it's going to be 89, and it's going to be 377, because J14 is going to be J11, which is the JX, with golden ratio to the power of the difference between 14 and 11. So this means to the power of 3. Now, I want you to try and find the difference yeah, okay, first let's try to see if we're actually reaching 377. I'll take a calculator, I'll put it on the screen. So 89, we start with the golden ratio 1.618 to the power of 3, and then this times 89. We get to 376.98629. Now, this is not because the calculator is wrong. It's because we haven't put the entire golden ratio. Let's try to put the entire golden ratio, which is going to be 5 to the power of half plus 1 over 2. So that's the entire golden ratio. So now this to the power of 3 times 89. And we get to the exact number, 377. But logically, we already know that it's supposed to give us the exact number. Like 89 should be a full 377, but it's not. That's what I mean. Logically, we did everything right, but the answer is still not entirely right. It shouldn't have a decimal.
Then that would throw our entire math out the window.
Exactly.
I feel really sad right now.
So yeah, I actually I stumbled across it in a more important matter, which I don't remember. I guess I kind of repressed that memory because I tried to actually test some of the theories that I learned in more advanced equivalentics using a calculator here, and I never got to the right answer, although I did everything right. I did it also in Pleiadian computers, and it came out right. It only came out wrong here. So yeah, that's an issue.
So how do we correct the calculator function in such a way where it's not relying on powers anymore? Like, how do we correct this?
It's not an easy task. And I am not sure right now because you'll have to fix every calculator in the world to be able to follow equivalentics and not mathematics. First, you have to tell that to humans and for them to be able to accept it.
What if we created that calculator just amongst us and then share it with humanity, like a software program, like
We
Uberon?
need a programmer because Uberine is more like a trick. It's a very not efficient trick that we use just Excel in order to create something that we have there by default, and it is and the reason we have it by default is because this is the base principle for a quantum computer. So maybe when quantum computers become something that everyone has in their own home, we could have the accurate calculators. Unfortunately, humans rather use the quantum computers to play with AI.
If we shared this information with LLM architects, do you think we could create such an equivalentics-based calculator with them?
Probably.
Okay.
But you would need like a cold LLM, like standalone, because the global powers will block you. You need something clean installed on your own computer, disconnected from the internet.
You would need it on a separate server of its own, I think.
Exactly.
Completely isolated.
Yeah, and then you could do it.
How does this work in terms of time calculation?
Oh, that's why time calculation is very wrong.
Right.
Well, also because, okay, so the time calculation is very important to use Mercury for it. For everything else, you don't need Mercury. But when it comes to the dimensions that has any touch with perpetual motion, you need a perpetual motion material to calibrate them.
That would mean it's Mercury, I see.
Mercury and gold, which is the same thing.
Now we're entering a whole tangent, but maybe in the after class discussion, you can share your civilization's version of the periodic table, which is very different from humanity's version.
Yeah, I'll give you the small explanation on Mercury, no problem. And it has to be not recorded because that specific information would get you in trouble. So so that's why I don't want it to be recorded.
Going back to the quantum computer cold standalone model, if one were to construct such a calculator, are you recommending that one use Mercury basically as well?
only when it comes to calculating galactic movements and time. For the more simple ones, it's just updating the software to a quantum thinking.
Thank you.
But you know, when I'm talking about time, I'm not talking exactly about time on Earth, because even that is not very accurate on its own. So this, you could use like a normal software to do that. And I'll give you an example. It would seem, people are, right now are starting to complain about it, that the seasons aren't exactly matching the months. And it's true, because our year is based on only one variable, which is Earth circling around the sun in a seemingly perfect elliptical shape, but it's not perfect. It's a spiral.
So judging by what you just said, you know, the current calculation of 365 point, what is it, 25 or 24 days that you're saying is not correct? Or
It's
that,
only sometimes correct. It's not always correct.
I see.
Sometimes we have an extra day. Sometimes we have less one day. And it has to do with its correlation with the sun, the solar system revolving around the source, around the center of the galaxy.
Right. But then is that not predictable in terms of, you know, going forward in time?
It is predictable, just not using 365 days.
I would like to see that calculation.
It's basically the revolution of the solar system around the center of the galaxy should be 676 days. It could be a little bit more than that. So basically, if we divide that in 365, then we get to the 185. No, sorry, I just don't remember exactly the calculation. I was shown that before, so I can ask.
I can agree and attest to the fact that the seasons have been shifting every year, ever so slightly in the human. I mean, I'm just a human, but I can detect that. So
Yeah.
it's very interesting.
It will be a bit more accurate if we were following a 13-month year.
That the 28-day model calendar?
Yeah. It would have been a little bit more accurate for longer, but it's still not entirely accurate.
Isn't there like a culture in Africa? I don't know if it's the Ethiopians that still go by that calendar system.
Yeah, they still go by that calendar system.
Right.
And for them, the seasons are more in place.
I see.
The only ones who are actually following the right one are the Chinese.
You're talking about the lunar calendar?
No, the Chinese are following that each year has a slightly different amount of days.
Right. Okay.
And that's the right model.
I see.
And the model that we are going through, I mean, Pleiadians, Nordics, we stopped following the calendar of our own revolution around our sun mass, and we started following the calendar on it revolving around the central axis of the galaxy. So we have 676 days in a year.
So how does the 676 relate to the 365 of ours? If that's from
This
your
is something I need to ask. I don't remember.
oh, okay.
But I mean, how we can use it, probably just like the Chinese.
Okay. Do you happen to know the name of the Chinese calendar that you're referring to?
No, but I can find out. Let's see. It's yeah, it seems it is. It's called the lunar calendar. Siddharth.
The lunar calendar.
Yeah.
Okay. And but that lunar calendar is based on the movement of the moon.
Which is more accurate because this is gravity.
Right. Okay.
This is gravity of just one object versus the sun is not just one object.
Right.
All right, so for the homework exercise, we need to find the difference between J3 and J7, J5 and J12, J9 and J15, using that formula. Same way that we did it here. And then these three are, you can refer to them as kind of a bonus. And I'll explain about the star system next. All right. So I'll send you that, which you can actually print. Yeah, in a moment. Does anyone have questions about that lesson before we go to the after class?
I'm going to need help with how to do that again. But I don't know if you want to do that now or.
Yeah, we can. I'll show you exactly how it works.
Okay, thank you.
So the way that this works, I'm giving you like the answers for the first one. It's going to be J3 is 2, as you can see on that table. So we're putting 2 outside of the brackets. Then inside the brackets, we're using the golden ratio, which is going to be 1.618. And then it's going to be to the power of the difference between J7 and J3. So 7 minus 3 is 4. And that's why I'm putting here 4. So 2 times 1.618 to the power of 4 would be 13, or at least something very close. So I'm taking 2. No, first I'm going to put 1.618 to the power of 4. And this times 2 would give me 13.
Okay, and you don't round it up, you just leave it at 13.
We leave it at 13 because we are aware of the problem the calculator had.
Right, okay. Okay, can I try? Maybe I'll even just do that one, like just going through those steps. Is that okay?
Or yeah, try to do it on 5 and 12.
Okay.
I sent in the group the highest number my calculator could reach in the decimal ratio. If you copy that and use that as your constant every time, it might get you to a more accurate answer. I guess not. Nika, did you try to use it?
Yeah, you know what? I'm trying to figure out calculator, which button for the power. So I'm doing 1.618 to the power of 7. So what do I have to hit on my calculator?
Y, I think.
What?
X to the Y.
X to the Y, right? Yeah, it was okay, good. That's what I wanted.
Oh, yeah.
Yeah, perfect. Okay, I got it now. Thank you so much. Okay. Is it 58?
Let's see. No, it's 29.
Hold on. Let me see now. Is the power 7? Is that correct?
Yep.
Okay, hold on. Well, yeah, I got 29, and then I have to multiply that by 2, no?
No, by 5, because we're starting from J5.
Oh, right. Sorry. Sorry, I was looking at the first one. I apologize. Duh, of course. One moment, please. So 145.
Right. And
Yeah, I had the
we
29
know that
before.
it's supposed to be 144.
Oh, right. Sure.
Yeah, so we're just writing what we know that it should be, although it isn't.
Okay.
Yeah, so that's how we do the rest of the exercise. Just reminding you that the last ones are a bit tricky. You'll see. I wanted to say one more thing regarding that. Okay, so yeah, these are the homeworks for the I remember now. It is also shown on the sheet here. Just a certain way to kind of remember, if you're not seeing that table always in front of your eyes and you're not sure which one of the Fibonacci sequence corresponds to which number of the J's. So just remember that J5 equals 5 and J12 is times 12, and then you have like anchors.
Okay, thank you.
All right, so now we're entering the after class, and I'll give you a small exercise on Mercury. All right, so I'm just reminding you that the way that we teach stuff in breeding culture is by questioning and being skeptic. So this is prompting you to be as skeptical as you can. And so I will ask you these very simple questions, and it's very important to always kind of think simple and not try to be smarter than it. Just be like a very skeptical normie, you can say. Okay, so can anyone tell me what are the uses of mercury in the last 5 centuries, to the best of your knowledge?
Measuring temperature.
What? Sorry, what again?
Measuring temperature.
Right, thermometers. So, okay, why do we use mercury for the thermometer?
it can sense any changings because it's liquid in room temperature.
Yeah, right. Fastest expansion from minimum heat. Okay, so scientifically speaking, we input heat energy and receive what? Is it more mass or more volume?
Volume.
Right, volume. Yes, which is happening naturally when substance moves from liquid to gas. Now, this is all still human physics, not flourish science yet. So in physical level, we input heat energy and receive kinetic energy, which is the energy of movement. This is a similar process to how an engine works. Now for the mind-blowing stuff. Why aren't we using mercury to power up engines? We are using it as an expander for thermometers, and we're not using water. Why are we using water for engines, but we're not using mercury to power up engines? Okay, so what is the boiling point of mercury?
356.7 degrees Celsius or 674.1 degrees Fahrenheit.
Okay, great. So what is the boiling point of water?
(100 degrees Celsius or 212 degrees Fahrenheit.
Right, so due to the boiling point of water, it is 300% more efficient to use water instead of mercury. So why aren't we using colored water in thermometers instead? Weird. We use alcohol in mercury in thermometers. The alcohol version is cheaper, but the mercury version is more accurate. We are even still using mercury in digital thermometers. We use alcohol because it's more sensitive to heat than water at its boiling point, which is 173 Fahrenheit. That's logical, right? Using alcohol for thermometers. But mercury? What the fuck? Why? That's just plain stupid, isn't it? Because actually, mercury expands faster, even faster than alcohol. That means it is sensitive to lower temperatures than alcohol and water. It may be just a theory here, because its melting point is lower than water at minus 37 degrees. Maybe. Let's put that theory to the test. How much is the total range of mercury between melting and boiling point? So what I'm asking you to find is basically the difference between minus 37 and 674.
It's about 395 degrees.
No, it's the difference between 674 and minus 37. So that would be 674 plus 37, which is 711.
Sorry, I was using Fahrenheit. I got fucked up.
Yeah, it is Fahrenheit. It's minus 37 in Fahrenheit, no? Melting point of mercury.
Yes, you are correct. I got 711 as well.
Yeah. It is minus 39 in Celsius. Okay. So it means that at, let's say, 100 Fahrenheit, the total spectrum cover of mercury at 100 is 137, because we're adding the negative values. And then this is divided by 711, which is 19%. That 19% is the efficiency of mercury in a certain temperature. So we are trying to compare it to water to see what is more logical to use. Let's do the same thing with water. What is the melting point of water? Or freezing point?
Zero degrees Celsius or 32 degrees Fahrenheit.
Right, 32 degrees Fahrenheit. So the total spectrum of water from melting to boiling is 212 minus 32, which gets us to 180. So now let's divide the 100 degrees marker by that spectrum of water. What do you get? 100 minus 32 is 68. And then 68 over 180 is 38%, which shows us quite in a very big difference that water is actually much more efficient and much smarter to use in a thermometer. So, fuck, now what? How can it be that mercury is expanding faster in low temperature, while all the science clearly shows that water should be more accurate and expand faster? So now it's time to get the big guns. Time for Mr. Alien, Florist Science. So in the physical level, we input heat energy and receive kinetic energy, which is the energy of movement. So far, human science. In the 4 laws of thermodynamics, we will receive an equal amount of energy to the energy we input. Heat equals movement. Now for Florist science. In the subatomic layers, we use a certain amount of heat to apply pressure and destabilize the structure of matter to change its state and make things move faster inside. Now remember this principle. The heavier the molecular mass, the more energy I need to invest in order to get it to move. Okay, we have a lead. Let's give it to the test. What is the subatomic weight of water in its most basic level? H2O. This is something you need to search in Google. Someone else other than Jerry.
Is it 18 grams per mole?
Right? And so now what is the subatomic weight of mercury?
It's 200.59 grams per mole.
Great. So now we have a verdict. Wait, no, fuck, shit, no, that's, damn it, that's that's not verdict. Even Florist science clearly shows that water should expand faster than mercury. Okay, look, we passed a great deal of research here, and here is what we have. Water is more efficiently used with engines because it turns to gas faster than mercury, meaning we need to invest less energy to get better results. Water sensitivity spectrum is almost 3 times more sensitive than mercury, and it is explained with Florist science since mercury is significantly heavier on the subatomic level than water, yet mercury still expands faster in a thermometer and in low temperatures. Doesn't make sense, right? Let's think together here. Okay, we invest heat energy in water and we get an equal amount of kinetic energy. we invest heat energy in mercury, and we get a bigger amount of kinetic energy. How can this be? Mercury is a perpetual element. It is used as an elemental accelerator. That is why it is so toxic. It's unpredictable. It defies all logic and practically decimates the 4 laws of thermodynamics. It's a complete violation of nature. Can you think of another massive violation of nature, an element I keep talking about as the great disruptor? Probably not with any of you, so I'll just say it. That's crystallized gold. Great. One last question. As some of you may know, an unstable isotope like uranium-235 and crystallized gold and many other radioactive elements undergo a beta decay process in which they emit radiation in the form of neutrino energy. And by that, they are effectively destroying their molecular integrity. They become something else, a different element. In flourish science, we call it polarized version of the base element. Can anyone tell me what normal radioactive isotope of gold, let's say gold 198, turns into at the end of its beta decay process? Again, search it in Google.
What, monoatomic?
Yeah, monoatomic gold. What does it become by the end of its life?
I thought gold doesn't change.
It does. Look it up on Google.
Mercury 198.
Right, mercury. So when gold loses its structural molecular integrity, it becomes mercury. And this is why I'm saying mercury in gold is the same thing.
That is crazy.
Both gold. What?
That is crazy. I don't understand. How is that possible?
How? What is possible?
It makes perfect sense. It's, yeah.
Neutron inside the nucleus converts into proton. So you're saying gold 198 becomes a much more stable version, which is the mercury 198?
Right, but they're still both perpetual. So you can create radioactive elements using 2 ways. One is investing a lot of energy, and the other one is through using a lot of pressure. When you use a lot of pressure, you get crystallized version of that same element. So actually, it was created before in a lab. It's just that crystallized gold, probably that's the only element, is very different on the level of crystallization it is in. It has completely different forgot the word for it, properties. So when they crystallized gold in lab, they just gave it different names. So there is americium, moscovium, and there's a few others. All of them are basically crystallized gold. The difference between our periodic table and human periodic table is that for every state of matter, they give an entirely different name. But we don't have a name for mercury. Mercury in gold is the same element. It's just in a different state of molecular structure.
I want to say something here. It's about natural law and transformation. That's why in alchemy, mercury and gold are related. So gold is when you have a structure, which is natural laws, you abide by them, and mercury when you don't. So it's, if they say, a person that embodied like, a gold state, golden state, it means he or she
have a structure. That's it.
Yeah. So crystallized gold is a perpetual element that is so powerful that it is very hard to take control of, because it's even more unstable than uranium. With crystallized gold, if you just leave it crystallized, it's going to enrich itself. While in uranium, it doesn't happen. It's actually using enrichment over time. So crystallized gold is very hard to control.
I'm thinking about what you're saying through the lens of Anil's sort of spiritual sort of ramifications, that if we are to achieve a sort of golden state, we cannot be controlled. We have to be self-sustaining and enrich ourselves.
Yeah, exactly.
That's breatharianism, by the way, in other terms. It all goes over, inside natural law. This is the point, becoming golden. But in the ancient days, they didn't speak it like this. They use all of these, elements, languages. But I have a question, Leo.
Yeah.
In nuclear energy, they use another substance, radium, palladium, something like that. I can't recall. What's the story with that?
There are different radioactive elements that are all emitting very powerful energy, neutrino energy. Neutrino energy, neutrons are traveling very fast, very close to the speed of light, not at the speed of light, but very close. And that's why they create immense amount of energy. And they don't always have to cause fission. They do create, they sometimes do create fission, and that's the heat signature that we use for engines. But not every time they hit another atom, they would create it. So delta radiation, which is the nuclear radiation emitted by crystallized gold and mercury, is much more powerful than beta radiation, that this is what is used in engines. And the reason for it is that every time a neutron hits another atom, it will always create fission. And with that always creating fission, it makes it very unstable and very hard to use. And what happens when every hit of the neutrons creating fission, it doesn't just create heat, it changes the molecular structure of elements around it. So basically, if you put a certain level of enrichment of crystallized gold next to iron, it will turn it into silicon. Naturally, iron will never turn into silicon.
So again, thinking about the spiritual alchemy of this and the ramifications, if we are to be crystallized gold beings, we can still evolve the other elements at play around us, and they may not reach the same sort of properties that we as in a crystallized gold state may achieve, but they do receive some level of evolution from just being within our circumference of influence.
Yeah, that's true.
I have a question, Leo.
Yeah.
So, I think a lot about substances. And for example, you gave us the example of iron. I always thought about what the states that they give us for these things, for these metals, and they tell us these metals will embody, just a couple of different states, and that's it. Maybe, and that's what I think about. it doesn't need to be like this. Maybe you can create all kinds of these things, just like in alchemy, just like with characters. You can create all kinds of these states, but with different technologies. So I always thought about this. If for example, you have a war and you don't have a lot of materials to create something, a weapon or something, but you have multiple ways to change one material, maybe that will be sufficient, right?
Yeah, that's what we're using. I mean, you probably heard in sci-fi movies and books about something called a food synthesizer, something that creates food out of thin air.
Exactly, right.
Yeah,
Exactly. That's. I mean, I have these things like in me, but I never, I never heard anyone talk about these things. I give an example. Taking iron, for example, like in shielding, right? When you have blades, when they want to armor tanks, something like create a shield. They say, well, this is the best level we can create with iron. That's why you need to have uranium shielding, like they use it in tanks or in ammunition, for penetration because it's harder. Maybe it's not. Maybe the way you're treating it, it's not it's not the ultimate way.
right. We're using a different kind. We're using basically iron on my home planet is considered rare, and so we never actually used iron that much. But we do use stuff like tungsten and aluminum and palladium. Yeah, so let's say we have some uses for steel, but not steel as is. We are using carbonated fibers of steel, which is carbon and steel together. This is either created by an immense amount of energy used to fuse them together on the molecular level, or with crystallized gold. We just
I have a question
fuses them
about that.
together naturally.
Yeah, I have a question about that. When you do that, will that create more space or will get the atoms closer together? Because, I thought about
Closer
perhaps
together.
if closer together, right? Mm-hmm.
It makes them. It makes the steel takes instead of the shape of cubes, it takes the shapes of the decahedron, which is the densest shape in the universe.
Yeah. I don't understand how people can see it like with spirituality. Like for me it's so easy. Like it's not just left mind. It's so easy to connect. To be intelligent, right and left. Mind and heart. I can't see how people can see it. They spend their whole lives in this so-called scientific movements, and and they can't see it.
Right.
It's so easy. I mean, just think about yourself while dealing with these elements, and that's it.
Right. So crystallized gold is something that is so immensely used in my home planet that it's everything that you see that is some kind of sci-fi. You eventually somehow find out that it was achieved using crystallized gold. Yeah. So someone else had a question.
Yes, I just wanted to, you mentioned, or Jerry mentioned before, something about the different periodic table. Is that something we're supposed to be seeing right now? Because I'm not seeing anything on screen. Or
No, there is no. I never actually created it because I need more resources with like a chemist that can help me realize which of the elements that we have on the periodic table were actually just duplicated by the human periodic table, and which of the elements that we have don't even exist on the periodic table. So like I need like someone who really understands nuclear physics and chemistry to help me build that periodic table here.
So what you're saying is like there are more elements to what we have, like infinite amounts of elements.
There could be infinite amount of elements, but I believe there is a finite amount because these elements are building blocks for everything else. Although I do
Just
know
like-
like there are some planets in the galaxy that have elements that don't exist anywhere else, as far as we know.
I see. Maybe it's different stages of the same elements.
No, there are some elements that are unique to specific solar systems, but they are still on the periodic table that we use, because every time we discover a new element, we put it in there, even though it's completely unreachable on our planet, because we Pleiadians, we cherish science on all levels, not just the stuff that we can use.